Hello, my name is Maya. I come from Israel, where Wonder Woman also comes from. I'm the BA team leader at myThings, which is based in Tel Aviv, and we have other branches in the US. Today I will talk about how we use Exasol. I personally believe that companies can learn a lot from each other, and hopefully you can get some ideas and inspiration from the way we use it. Today I will talk about our business, technology, and two use cases that demonstrate the power of Exasol. So let's start with myThings. myThings provide programmatic advertising solution. It delivers a personalized experience across the entire customer's journey. myThings is an ad tech big data company. We provide full funnel solution for the major e-commerce retailers. Among our customers, you can find Michael Kors, Vistaprint, Nordstrom, and many others. We develop a sophisticated real-time bidding platform, which is connected to the major real-time bidding exchange, including Google, AppNexus, and Twitter. The platform is based on a set of advanced machine learning that adders decide in real time how much to bid and what to present to the user. The platform received billions of bid requests per day and has to process it less than 20 milliseconds. myThings is a classic big data company. We collect activities from users all over the web and delivered a personalized experience. So how do we collect all this data? First of all, we provide the advertiser a set of JavaScript tags that they implement within the site pages. Then, when users visit the website, we collect all the conversions and visits that the user makes. Later, the events are arrived to our data center, and we collect all the user activity in user store. The technology that we used called Aerospike, which is an ultra-scalable database. Next, when the user visits a publisher content site, for example, CNN, the site wants to show the user a banner. For that, it's called the real-time bidding exchange, for example, GDN, Google Display Network. The exchange is functioning like a marketplace between the advertiser that wants to deliver ads and the publisher that wants to show the user a banner. Now the exchange is sending to myThings bidder a bid request, as well to all our other competitors. Now each entity has to decide how much to bid and what to present to the user. myThings bid calculation is based on the machine learning models. We run models on the data to try to predict what is the probability that user will click, convert, and also the average basket value. The platform also needs to choose which banner to show and what is the recommended product that will be in that banner, that I will explain later. So all the events, visit and conversions from the user activity on the web, impression and click from the interaction with the banner, bid request and bid response from the bidder are streamed using Kafka technology to our analytics cluster. Kafka is a scalable message queue technology that allows to stream a large amount of data in an effective way. That brings us to our analytics cluster. So our analytics cluster contains two units. The first is mediation cluster, and the second is Exasol. The mediation cluster is 1 petabyte of Hadoop cluster that contains all the events in hourly aggregation. And we also have archive data, which is a raw-level data that can be exported to Exasol. After this, we have the data warehouse, which is Microsoft SQL Server for billing and aggregation. Then we use OLAP cubes for fast analyzing. And finally, we have the OBIE, which is the BI reporting tool of Oracle that connects to data warehouse and also for Exasol. And the second cluster is Exasol. It contains the most recent raw data that is available to our data scientists and analysts almost in real time. The cluster contains 8 nodes of 20 terabytes of data. Before Exasol, when we run queries on the old solution, queries could run for 12 hours, even more, and sometimes never finish. We tried a cloud-based solution, but none of them provide the required capabilities. there was missing functionality and with a lot of limitation, and Exasol just worked. From the beginning, it was very easy to use with Exasol. The query runs for 3 or 4 seconds. And it was clear the analyst wanted Exasol. Now I'll explain about the process of how we're loading data into Exasol. As I mentioned, the events are streamed with Kafka. First, we have the consumer, which is Java program that's responsible of transferring protobuf format into CSV format, save the data in local disk, and zip the data. Then we have DB Writer, which is also a Java program that's responsible of pulling back pending data and insert them into Exasol. As a convention, we decide not to store varchar column in our fact tables. As a result, we will generate 64-digit hash key for each varchar column that will save in the fact tables, and we also create a lookup table for the hash key and the original varchar. If we take an example from our database, one of the varchar is URL. A specific example is CNN.com. As you can see in the fact tables, we have the dimensions, date, and URL in a hash key format, and the lookup is a URL GK and URL, which is the original varchar. If analysts want to query the data, you know that you have to make join between these two tables and reveal the URL. All of our analysts know that for every varchar column, we have the relative lookup table, and we have thousands of lookup tables. As I mentioned before, the DB Writer is responsible of loading data into Exasol. But in the lookup case, we have a lot of repeating data. If we take an example, the CNN case, we don't need to generate each time a new hash key and to store the original varchar. We need to do it only once. For that reason, we created an additional process that loading lookup fields into staging table, and then upsert the data into lookup tables. The upsert is updating existing data and insert new data. And this is how we avoid the duplication. I'd like to highlight 2 use cases that demonstrate the power of Exasol. The first is linking ad campaigns to a real-time event, and the second is about our product recombination with MongoDB and Exasol. Let's start from the first use case. So we export data from Exasol into SQL Server, and we also import data from SQL Server into Exasol. In addition, for billing, we also keep all the campaign configuration in SQL Server, which are present to our customers in dashboards and reports. In Exasol fact table, we have only the ID of the business entities. For example, publisher, advertiser, campaign. If an analyst wants to query the raw data from Exasol, you know that you have to reach the full attribute of the business ID, which is stored in SQL. For example, if you want to know the name of the campaign, when it started, or by who, you have to reach the SQL. For that reason, we created Exasol connections, which is connection string to Microsoft SQL Server, and a set of views that reveal the actual configuration data. Now, in one query, we can combine the Exasol fact table data with SQL configuration data. And we also export data from Exasol into SQL Server. For example, if we want to know the unique number of visitors or users, this is something that we need to export due to the hourly aggregation in SQL Server. The second use case is about our product recombination. So basically, our product recombination is used the product details, which is stored in MongoDB. Before Exasol, the algorithm used a dupe with MongoDB, and it was much more complex and not easy to change and maintain. I will explain why this process is complex and how we did it with Exasol. So basically, our banner personalized and dynamically created with recommended product, which is based on the product recombination algorithm decision for each user. We employ a collaborative filtering algorithm that provides a unique recommended product for each user, which is based on the product that the user interacts with, add to cart, viewed, purchased, matching it with similar user activities. If we take an example, if I'm on the web and I purchase a shoe, and then we look at a similar user to me that also purchased a shoe, and then purchase a dress, we can figure it out that I will be also interested in that dress and will be added to my list. But in the other end, if we look at similar user to me that purchased a shoe and then didn't purchase a book, we try to avoid this product and it won't be added to the list. Basically, the machine learning algorithm is used to analyze thousands of data elements to try to predict what is the most recommended product for each user. The basic list contains the event date, the product ID, and the user ID. After we have this basic list, we need to add more information about the product to make the list much more relevant. For example, we need to know if the product is available. If it isn't, we need to remove it from the list. Another example, if we have users that we don't have much information about them, and we have a big list of products, we want to show him only the best seller, the most popular product in the category. All this data is stored in MongoDB, which is data that we take from our customers every day, and also can be updated and changed. The price, the name, the availability of the product. MongoDB is a document-based NoSQL database, which is highly scalable and used by our real-time bidding in the bid time. The format of this database is key and value. The key is the product ID, and the value is the product details. For example, picture of the product, price, name, availability. And finally, our product recombination algorithm developed in SQL and runs on Exasol. It uses the raw data from Exasol fact table, which contains all the conversions and visits that the user makes. However, Exasol fact tables contains only the product ID and all the product details had to retrieve from MongoDB. For that reason, we used Exasol UDF scripting. We created a Python code that receives a product ID and return all the product details in table form. The Python code retrieves data from MongoDB in JSON format, flattens the data, and inserts it into Exasol. This process runs every day or by demand if we have a new advertiser or a new product, and this is one of the most important processes in myThings. This is an example of how the script is work. It received a product ID, and the result is a combination of advertiser product ID from Exasol fact table with MongoDB details, the name, price, and stock status. I want to show you a short demo of how the product recombination works. So, first of all, we have the first impression. We don't have any information about the user, and we want to show him only the best seller, the most popular product. As you can see, women like to buy bags in Michael Kors. Now, the user visits the website, and we can see that he makes interest in shoes. All this data is streamed to our data center, and we store all the user activity in Exasol. Viewed, add to cart, etc. Now, this is the second impression. You can see that the banner is changed due to the user activities. We can see the last viewed product, similar product, and product that most likely the user will buy with this shoe, which is based on our product recombination algorithm that runs on Exasol. It is clear now that Exasol plays a critical role in myThings. by making the process much more easier, we have more time to focus on analyzing the data and create complicated features. We use it every day, and it helps us to make a business decision. Thank you.